This topic was discussed also on the Mumbai local chapter WhatsApp group. And often we are hearing about the various technologies, various options which are available for decarbonization. But there are also associated costs with that. And there are various environmental impacts, whether we talk of the non-renewable renewable energy system or nuclear or conventional oil-based or coal-based industries, all those power plants. So, because if we are generating energy, we have to pay some price. So, a proper assessment is necessary for this. So, I will just formally introduce the speaker of the day. He has been associated for last 40 years with the oil and gas, refining petrochemicals, renewable energy, sustainability, biotechnology, etc. And he has been with Reliance in India as well as ExxonMobil in USA. And right now he is in USA and he has agreed to give this online webinar. So welcome and good morning, Dr. Ajit Sapre, for this talk. And thanks for accepting our invitation to give this talk. So I think now I will hand over to the speaker of the day, Dr. Sapre, and he will deliver his talk. Thank you.
So thank you, Dr. Singh. It is an honor and privilege to give my personal perspective on economy, energy, ecology. And as I was saying, it's really an honor and privilege to give my personal perspective on this topic to this august and learned audience with a deep scientific and engineering technical excellence. Some of you may be wondering what a chemical engineer with an industrial background can say anything about this complex subject, but let me assure you, I've been involved in this business for more than 30 years. And I do have some thoughts that perhaps may be worth sharing. Just as a background, I worked for 30 years in ExxonMobil. Perhaps you may know ExxonMobil is the largest private sector oil company and petrochemical company from the US. And now for the last 15 plus years, I've been associated with Reliance in India. So I do have a perspective both from international as well as Indian perspective. If you look at on this slide, the India's G20 message of one earth, one family, one future, Vasudhaiva Kutumbakam, is really the right one. And then in my mind, how do we go beyond just the slogan and make it actually happen? That is really the call of the day. So let me begin. This is a standard disclaimer. Basically, it says that whatever I'm going to talk about are my personal views. In no way reflect, certainly not the Reliance and not even ExxonMobil corporate view, if you will. So take it as it is, and you can ask me any questions at the end of the day because I've been doing a lot of work in this area for quite some time. As you know, the glaciers all over the world are retreating, and Himalayan glaciers are no different. They are retreating at about 0.6% of area. And then some claim that India is at the risk of flooding in coastal cities and losing its major rivers, source of drinking water and irrigation to more than 1 billion people somewhere in the neighborhood of 2050 or beyond. And so the simple message is that humanity must realize its aspirations within the safe boundaries of our Earth systems. And I'll talk a bit about this to the extent I know. But before I get into this, since you're a learned audience, I do want to give a preamble that says the job of the intellectuals, artists, and scholars is to try and go deeper, to try and see the complexity of reality, especially in today's climate of the post-truth. It feels intellectually, emotionally lazy just to pick a side, whether it is a green side or the fossil fuel side or whatever it is. And I guess I'm going to try and paint a very diverse and extreme views to stimulate the discussion. So it could be a somewhat enriching, and especially for the young in the audience or young at heart, perhaps they'll understand what are the challenges they'll be facing tomorrow. So the overall presentation is in 4 broad buckets. Talk quite a bit about my perspective on global ecological challenges and the system complexity. I'll talk a bit about economy, and I'll talk a lot about economy, just as I talk about energy. I wasn't going to talk about technologies, but I thought about I should mention some of the really path-breaking, first to the world technology developments that my group has done in Reliance. And it's worth talking about because that kind of says that we do have an ability to do something. And that will come in the context of what I want to talk about as a green oil. And so certainly, since I'm talking to the Indian audience, perhaps it may be worth talking about, if you really want to achieve Vasudhaiva Kutumbakam, what can we learn from the Indian past philosophy to really assure a sustainable and equitable future? All the data presented in my is a peer reviewed or from financially repeated reports. It's extremely fast-paced presentation. It will be visually dense, but the bottom line is just you read the title and the tagline, and you'll get the message and listen to my story. So certainly, if you think about it, the rate of fossil fuel consumption, the human prosperity, and population growth have gone hand in hand. The dotted line on this chart is really the population growth, and then the various colored elements are essentially different types of energy. There's a lot of exciting things that are happening in renewable energy, but the bottom line is the net renewable energy penetration is still not meeting on a global basis overall increase in energy demand. By the way, this is a global challenge. So we may think about everything's tremendously great in India on renewable energy. That's great. It's necessary, but not sufficient, because the climate change has to do with everything that goes on in the rest of the world as well. And to be honest, the capitalistic hypergrowth economies of the post-industrial revolution, essentially based on fossil fuels, has helped improve standard of living of increasing masses. And I'll emphasize the word increasing masses. So there has been a tremendous boost to the humanity, but obviously there are some serious consequences that we need to deal with. And a lot of people talk about technologies, this and that and other stuff. To be upfront with you, technology is such a small component of this. We have to understand the challenge in the entire Earth system. The human systems are just a small part of it. And then some of the complex issues of political, economic, and social behavior of 8 plus going to 10 billion people. And how do we solve this problem is a real challenge. And the issue really is the rate of Earth system change is accelerating. And I'll talk a little bit about that. By the way, I've been involved in climate science in mid-90s. When I was working for ExxonMobil, they had a very large group thinking about, and I'll talk a little bit about it later because I was involved in building an economic model for the world for 100 years. That has some consequences of what we are doing today. So let me begin and talk a little bit about Earth systems to the extent I know. And the atmospheric greenhouse gas impacts almost all the Earth systems, and whether it's a biosphere, a cryosphere, a hydrosphere, we focus mostly on atmosphere, but other spheres are just as equally important and perhaps not more important. And I'll talk about that as I go forward. I'm not going to touch upon every system. I could, but I don't plan to. Let's give some glimpses of, say, let's look at the biosphere integrity. There was a recent article last year on Science Advances that basically a bunch of scientists have claimed that the biosphere integrity has been transgressed for the safe operating space for humanity. So keep this in mind. Essentially, the way to look at this is a Mother Earth's perspective, and Anthropocene is us, basically, contribution. And I'm not going to go through all of these, maybe focus more on the climate change, but I will talk about the biodiversity just because I love animals. Anyway, it's a planetary scale crisis, and our world is deeply degraded compared to where we were. And let me emphasize again, the real issue is the rate of change. Both the scale and the scope is too fast related to the mitigating steps being contemplated with the risk of uncertain, unplanned outcome. So you need to have plan B, plan C, plan D. Plan A alone will not survive. So let's look at the biodiversity. We are the apex predator on this planet, and we have decimated the biodiversity of the Earth. And this chart simply says that if you look at the living livestock mammals, the 90% of the global biomass is to serve humanity. There's only 6% is wild animals left in the world. And by the way, any moment I get, I go to safaris or spend time in nature, because that jungle is far safer than having worked 45 plus years in a corporate jungle, if you will. We have done the same thing to the birds. Most of the birds today are nothing but the poultry, if you will. So today there is more artificial stuff by weight than the mass on the living organisms. And that's something we need to pay attention to, because if we don't reconnect with the nature, we have a hard time to think about how we're going to survive long term. I've been to Antarctica last year, and I guess this story just caught my eye just last week. National Geographic, for the first time ever, videotaped that the penguin chicks are jumping off the cliffs, 15, 20-story tall, as shown on the top left-hand side. And essentially, many of them will die just because when they hit the deep ocean, if you will. And the reason is that because the ice, sea ice, where most of these penguins used to live, has been melting way too fast, and now they are breeding actually on the permanent ice shelf. So by the way, Antarctica is warming twice as fast and is going to contribute far more to the sea level rise than anything else. Here's a picture of, in fact, the Antarctica experiencing heat wave last year. So anyway, the picture at the bottom left is what I took when I was on the trip in Antarctica. And you should pay attention to the top half of that picture where you can see green growth. And this is algae. And by the way, I know something about algae and photosynthesis, so I'll talk about that a little later. What we really want to see Antarctica is what is at the bottom left-hand side of the picture. And the fact that there is a green mass growing in Antarctica is a really a worrisome sign, not just that the emperor penguins may just disappear at the end of the century. And there are a lot of different scenarios, and there are a whole bunch of people talking about what is likely. To me, a temperature is not really a real measure, but let's say in a scenario we talk about temperature rise. The current policies are going to take us somewhere in the neighborhood of 3.5 degrees warming. So we had to be prepared for 3.5 degrees warming, and I'll talk a little bit about that, what exactly we need to do other than this energy transition that everybody's all hung up on. In fact, in my mind, we may be reaching probably 4 degrees centigrade by the end of the century. Now, the last summer was the hottest ever, and most likely it will be the coolest ever that we will see. And the climate change impact is uneven. Countries closer to equator will have far severe impact, and India needs to think about it as well. That we are much closer to equator, and it's a global problem. We're not going to solve it alone. So what do we need to do? And the rate of recent temperature increase is much higher than anticipated by any model, and I'll talk about a little bit about that why. Most people attribute it to El Nino that's happening this year. But really, there's no trend that suggests when El Nino appears, we'll come back to the original trend. In fact, all projections will continue on the same trajectory, increasing temperature. If you look at the this year's last month, March, we already exceeded 1.5 degrees centigrade, the Paris Accord. Now, obviously, we look at the annual averages, so maybe it may cool off a little bit, but we are on a trajectory to be much warmer than 1.5 degrees centigrade already. Now, all of you know that the atmospheric concentration of greenhouse gases is steadily increasing. Most of us really focus on CO2, but really they have to worry about methane, nitrous oxide, and others. Now, the pre-industrial atmospheric CO2 level of 275 ppm equivalent. Now, we have today more than 500 ppm CO2 equivalent when you include all the gases, not just CO2. And in my mind, ideally, we need to be closer to 350 ppm CO2 equivalent. Just to put in perspective the complexity and the scale of the problem, today humanity consumes close to 10 billion tons of carbon, keep us warm and run our factories and do all the other activities. And I'll talk a little bit about that later, which is equivalent to 37 billion tons of CO2 and more like a 50 billion tons of all net greenhouse gases, which is 20 times more than the food we eat and 10 times more than the water we drink. So just keep in perspective, the amount of carbon we use is far more than what we drink and eat. And that's the problem we're trying to solve. There's a graph at the bottom right-hand side says, okay, if we meet some net zero targets, we could meet 2 degrees centigrade. Likelihood of reaching 4 degrees centigrade is probably higher. And the reason is very simple. This climate change, and you may look at the greenhouse and all that nonsense, it has absolutely nothing to do with it. It has to do with the net energy imbalance that Earth has. I mean, Earth gets energy from sun, we radiate the energy back, and the Earth's albedo is dimming for various reasons, not just because the ice sheet is declining. Also, SOx is being taken out and a bunch of other things. But overall, Earth's albedo is dimming, so overall Earth energy absorption has gone up. And as a result, the sensitivity of the Earth systems is far greater than any models that we have ever produced so far. And so if you just put in perspective, amount of energy that has gone in, and somebody has calculated this in terms of the atomic bombs, and since you're sitting in BARC, know a lot about atomic energy, I thought I'll put it in. The amount of energy that's going in every second is equivalent to 15 Hiroshima bombs in the oceans today. And so to be honest with you, we have increased the Earth energy imbalance factor of 5-fold in just last 20 years. And that is worrisome. And the global warming is really rapid ocean warming. And you may be worried about the temperature and heat in where you live. But we are really more worried about is most of the heat is actually in the oceans. And what does it mean? When the oceans warm up, you're going to have intense hurricanes, cloudbursts, extreme heavy rains in short period, deadly floods. And I've just picked an example of what happened in Acapulco, a big city on the west coast of Mexico, which is essentially wiped out. And the reason I picked it up was that we thought we understood something about weather patterns, and we are now able to predict ahead of time what's going to happen. And the top right-hand side of the chart basically says the lines which are going horizontal are basically 5 different or 10 different models. And what actually happened is the line that is just going straight up. So the intensity by which this hurricane increased within very short distance in a very short period of time was not predictable by any model that we have ever produced. And this is the point I'm trying to make. What we think we understand is probably not true. And this is something we need to worry about. And that actually talks to about the fact that the overall sensitivity of the Earth systems is far greater than we ever anticipated. And these things will happen more and more. Now, the people were talking about the Dubai deluge, whether it was cloud seeding or anything else. But to me, it's a lot more to do with the much warmer oceans. Now, certainly the warmer oceans also have contributed to the hotter skies. And the hotter skies actually churn very differently. If you think about the polar jays and subtropical jays, they've been changing. And they've been changing much rapidly than anybody anticipated. And it was really curious. Just last week, US Department of Agriculture released entirely a new planned hardiness zones because they're worried about catastrophic agricultural losses. And so they're actually promoting what sort of crops the farmers should think about in the US context. Perhaps we should think about that in the Indian context as well. Many scientists are predicting catastrophic simultaneous crop failures likely in the future. I don't know when, but certainly by year 2500, life will be very difficult. And I'll talk about in the economic context what it really means. But it is something we have to worry about in terms of the Indian future monsoon. Because people talk a lot about tipping points where people talk about what's happening to resin Amazon rainforest or permafrost thawing or Atlantic circulation. By the way, the AMOC is something people have been talking about because it's one of the biggest system of overturning oceans and circulation, and which has been slowing down but has been accelerated in terms of its slowness. And that is going to have major repercussions to many of the weather systems in the world. And the tipping points are really reversible cascading feedback effects, because once we reach them, we're not going to get back anytime soon to the previous stable state. And so if you think about it, this is really a recent report. Well, last month at the University of Exeter, it's like a 700-page report, I think, talks about various tipping points, mostly negative, some positive. But at the end of the day, what they're really worried about is the AMOC. And so that is this purple vertical line on the left-hand side. And the ocean currents, if they slow down, certainly will affect Northern Europe, will certainly affect America. But if you also have to pay attention to this red bar that cuts across near the equator, which is far more critical for the Indian subcontinent, which is a tropical clouds and circulation patterns, and they are actually shifting much further south. And so most predictions are the Indian monsoon will likely shift over a midterm in next 30 to 50 years further south of Indian southernmost point, if you will. The only thing is that we will get an early warning, at least a 10-year warning, if you see that happening in the West African monsoon, which will happen much sooner and earlier than probably what will happen to the Indian monsoon. So, and by the way, this is one of the reports. In fact, if you look at all the NASA reports on what's happening to the weather patterns all around the world, there is a worry about what's going to happen to the tropical seasons. And so we need to worry about it. Now, if you think about the climate change and water crisis are also related, and we are pretty much running dry and drowning in denialism. I mean, what's happening in Bangalore is just a one instant. And this is, the Indian water table has been dropping much faster than any part of the world. And we've been essentially taking out the fresh water and depleting our aquifers. And by the way, the fresh water is only about 0.8% of the total water in the world. So the small variation in water cycles, because when the earth warms up, the oceans warm up, the amount of water that goes into the atmosphere is far greater. Every 1 degree centigrade is approximately 8% more moisture. And that has tremendous effect on the entire water cycle, not just the carbon cycle or the biological cycles. So freshwater demand will outstrip by supply 40% by some estimate by the end of this decade. So there's nothing more basic to life than fresh water and obviously food that I talked about before. So let me talk about this whole thing about net zero. And how did the people come to this 2050 as a great timing where we need to reach net zero, or 2070 for India for that matter? And it has absolutely nothing to do with anything. It has to do with this some report that this global carbon project came up with, saying we have so much carbon budget remaining, and that gives us 30 years to save us. It's a very simplified model. It does not take into account impact of recent SOx emissions reductions because we took sulfurs out of the fuels, but it does not take into account the cascading effect and the tipping points I talked about. And it's a very optimistic outlook on enforceable global treaties and so on and so forth. I've been paying more attention to financially savvy people like actuaries, and I'll talk about that a little later as I talk about economics. But essentially, from their perspective, and this is, by the way, the actuarial world global body, not some US body or Indian body, and their conclusion is that we have much less time and there's a lot less budget, and they're looking at purely from the financial losses perspective. So we have somewhere between 10 and 30 years, according to what I have presented, before the earth gets into irreversible, irreparable damage. And it is going to impact food, water, energy, all the key elements of human well-being. So anyway, Bill Gates wrote a really very simple book, easy to understand, and he just says what would it take to avoid the climate disasters. And essentially, every human activity, from making things like cement, steel, plastic, electricity itself, growing things, getting around, like transportation. And by the way, people focus quite a bit on the electric car, this and that. To be honest with you, more than 70% of the CO2 emissions are related to industry, shipping, and electricity production. So we may clean up our cities by putting electric cars. It's going to have a diddly squat impact on reducing anything to do with the climate change. The most important point on this slide is perhaps there are 2 points that you need to take notice of. All the technology we talk about, and we can talk about technology till the cows come home. I can give a separate talk upon all the technologies related to energy. But there is a green premium. That means they are more expensive than what exists today. The only technology that doesn't have a green premium that makes use today is really heat pump. Even solar energy, if I were to provide 24/7 reliable energy, is not cost competitive. And I'll talk about that a little bit later. How could you make it more cost competitive? And certainly, if you think about it, this is really, we are approaching a transformative moment in human history. We have never done this in our entire history of last, God knows, 10,000 or a million years. And certainly we need to rebuild the entire energy and economic structure in less than 30 years. And what we have done post-industrial revolution capitalism most likely may not carry it. And then, by the way, I'm going to give extreme views to stimulate discussion. I may propose some middle path, but just to get into your head, this is not some simple problem where you hear some headlines in newspaper and get excited about. Anyway, what exactly is net zero? I mean, this is a very simple picture. There are certain elements where we are emitting these greenhouse gases, and there are a couple of elements like the CO2 coming back into the oceans or into the land mass. And the whole idea is that if they come into net zero, probably Earth will be stable. But we must understand that the CO2 impact lasts for more than 300 years. And so certainly we had to suck out the CO2 as well. And where would you suck it out? A lot of people think we should be sucking it out of the air. Probably it's far more relevant to suck it out of oceans because the concentration of CO2 in ocean is far greater than trying to do it. Anyway, if you look at the current emission rates, certainly China, which is factory to the world, has the highest CO2 emission rate, followed by US. India is pretty close to our today's emissions being close to what the European Union is. But really, as I said, what matters is the cumulative emissions. On a cumulative emissions basis, India is only at 3%. So historically, we have not really contributed much to the climate change, but certainly as our economic aspirations are growing and as we hit larger and larger GDP numbers, we need to think about our contribution as well. And especially if we become a factory to the world, then they become our, and this is kind of it's really a ridiculous way to look at it. Because why are China's emissions so high? Just because they become factory to the world. And should they be penalized? And I'll talk a little bit about this in economic models of what should get penalized. So anyway, all of you know about the Paris pledges and all the other pledges. So I won't bother you with the details. But the trouble is 1.5 degrees centigrade has zero meaning. Just because the temperature rise is much faster, and United Nations now is talking about code red and trying to appeal to the countries that they should accelerate the net zero targets. Whether the countries will do that or not is really anybody's guess. There's no certainty, there's no binding a worldwide enforcing agency. So probably business as usual may continue. The more important thing is to talk about the global methane pledge, and this was something talked about the recent COP. And by the way, since India is trying to promote more natural gas, biogas, and other things, we have not signed up to this treaty. Neither China nor Russia. But this is a near-term opportunity because the CO2 problem is much tougher than solving a methane problem, at least in my mind. And if we can control the methane emissions, probably that will buy us some time to combat the CO2 issue. Now, if you look at the methane emissions, they have been accelerating recently, as shown in this bottom right-hand chart. And it's partly to do with the wetlands are actually emitting far more methane. And by the way, if you look at the natural methane, it's all from wetlands and the permafrost. So both permafrost thawing, but certainly about 50% of the emissions are still under our control, which is related to livestock, oil and gas, coal, and landfill. Is something we must pay attention to. So anyway, there's a lot of skepticism and denialism about human ecological impact, especially climate change, which is captured in this cartoon. And essentially, if you look at the bottom left, it says, oh, maybe it's a big, huge opportunity for business. And so the richest economies with fossil energy powered growth are resisting their obligations. And although there's a UN charter that recognizes common but differentiated responsibility, it's just a moral argument. Probably nothing is going to happen with it. So we need to pay attention to that. So anyway, let me come back and talk about what exactly is the energy and what exactly is prosperity for humanity. Because at the end of the day, we only have one Earth. And the real question is that can we grow forever from finite Earth? And so if we look at simplistically economy, we're extracting natural resources, factories and businesses are creating products and services for the people. And then as a result, there's economic growth, there's hyper-consumerism, and there's a waste and a pollutants, and the CO2 being just one pollutant, if you will, because the entire economic system today and the financial system is based on growth. If there's no growth, obviously this cycle will change. And what exactly are people? I mean, you can look at it from two different perspectives. People are workers, but most importantly for the economy, they're consumers. And this consumerism is what is really driving. And so to put in simple perspective, when I built the economic model of the world 30 years ago, compared to where we are today, amount of resources we have extracted in the last 30 years is more than previous 200 years. So keep that in perspective. So there are two schools of thought. One is techno-optimist, which I'll talk about next. Another is a degrowth, that we need to somehow figure out how to reduce the consumer hyper-consumerism and the consumption-based economies. So anyway, this is my view on what is ultimate sustainability, because I did have two questions right on my slide. What exactly is sustainability? And this is something we need to think about, because something I've been spending quite a bit of time myself. And if we just forget about nuclear energy for the time being, the only energy that Earth gets is from sunlight. And maybe there's some geothermal, but it's minuscule. So if you think about what is exactly, there's a lot of talk about circular economy, and I can talk about circular plastics and everything till the cows come home, because we've done a lot of interesting things in that area. But if you look at the circular equilibrium for the Earth, and it has to stay within the regenerating capacity, it all comes down to just understanding photosynthesis and its impact. So we need to live within the photosynthetic energy budget of the current biological cycle. The only reason our economies are prospering is because our society exists at a capacity greater than regeneration capacity of the Earth because of infusion of fossil energy. And is this ultimate utopian vision possible with our current economic system? Is a real question. So let me talk about energy is the economy. And then the real question in front of all the politicians is that save the economy or environment? That's the real dilemma. Because energy is the fundamental currency of life. Money is nothing but a call on the products made by energy or services made by energy. So without energy, there's no economy, and you would understand that exactly, because everybody talks about GDP all the time. Now we have two choices. And how would we achieve a soft landing on climate change? The growth paradigm that the hyper-consumerism will continue and will somehow rescued by the green technology is one option. Other option is that you essentially cut back. And neither option is socially palatable. It is going to lead to chaos and economic collapse. And let me bluntly tell you, we collectively do not know how we go from today to a truly sustainable future tomorrow. Neither techno-optimism nor rapid degrowth ensures soft landing. I'll propose something from the old Indian philosophy. And if you really want to achieve Vasudhaiva Kutumbakam, what is the likelihood? If you just simply think about it, I mentioned it before, most of the energy consumption CO2 is because of industry, heavy industry, if you will. And if you think about machinery, mining, the diesel fuel is really the source of all the high-tech civilization of today. Without that, there's no mining, there's no transportation, there's no agriculture, at least not to the extent at a meaningful scale. And contrary to all this happy talk about electrification reducing crude oil demand, there's no ready replacement for this high energy dense versatile fuel. And I talk about this high energy density a little bit later. But the real question is, are we willing to destroy our planet to maintain our economic growth? And so there are two, and this is a simple cartoon. And when I was young and when I was doing a lot of technology, and I still do a lot of technology development, commercialization, I was more like a fox. I'm very optimistic. Technology is going to solve all the problem. As I get older and think a lot more about the world, how it works, I'm becoming more like a hedgehog. So hedgehogs are what? To them, the foxes are like techno-optimists, and to the foxes, hedgehogs are like this know nothing systemic pessimist. By the way, I'm neither. I just want to paint a picture so it lives in your mind. What is this whole parable of foxes and hedgehogs to understand what the real challenges are? And if you look at the optimistic view on green energy, electrification, and decarbonization, they are summarized here. And I won't read it because you read this in a newspaper on every other day. I'll talk a little bit about it, what really does it really mean. And to be blunt with you, it is the economics at the end of the day, amount of energy and money needed to do this. It doesn't even cut the mustard. I'll talk about that on the next slide. All these net zero pledges and investments are unlikely to solve ecological disaster because the rate at which the investments are happening versus the rate at which the ecological disasters are happening are not in sync at all. So to me, it could be a triumph of hope versus practical reality of green. And then, by the way, remember this word green premium. There's not a single technology other than heat pumps today that actually is economic compared to our current existing energy sources, if you will. And certainly there's a political unwillingness to burden the economies today with a higher cost. So let's look at economics. And I'll talk about economics that I did in mid-90s when I was working for my previous employer. But if you look at all the McKinsey's, and there are a bunch of other consulting firms as well, almost all of them will come back and say we need to spend at least 10% of the world GDP from now on till eternity every year. And that is close to $10 trillion or more. And today we are not even spending a $1 trillion on the green energies, if you think about it. And if you think about all the solar, wind, batteries, all this stuff we're talking about, it's going to require significantly higher amount of mining, and mining consumes a huge amount of diesel energy, by the way, today. Okay. So anyway, the reason I pointed out it was I was a part of the team in my previous employer to put together a 100-year plan for my previous employer. They're one of the largest oil companies in the world, if you will. And then they're really not just an oil company, but they're more of an energy company, if you will. And the issue was, what would it take? And so we did put together a world economic model, worked with a whole variety. In fact, we also had a very large team working on nothing but the atmospheric sciences. And since in those days, there were no IT companies, we had the biggest supercomputers. So we were running all these atmospheric models and the various systems, Earth systems that I talked about. But more importantly, I talk about economic models because we did looked at every sector and every major economy and its potential growth rate for next 100 years. And just to put in perspective, in 1995, number of cars that were in California alone were more than India and China put together. So just think about it. The world economy is only 1/3 of what it is today. And even at that time, we thought that world will have to spend 10% of its GDP, and there's no political will to spend that kind of money, and that hasn't changed. It's kind of interesting. The problem has gotten much worse, and that's about it. So anyway, coming back, why isn't it a big crisis in the northern countries? And at the end of the day, why are we talking about temperature? And it's really, we should be talking about CO2 equivalent in the atmosphere. That's the real measure. And the only reason we're talking about is the northern countries are really worried about migration. And once the wet bulb temperature goes beyond 36 degrees centigrade, there'll be mass migration. I'll talk about that in a little bit later. But even at a 2.5 degrees centigrade, most of the northern countries are still livable. Part of India may become unlivable, but it's not really a big concern and not a populist movement in any rich country, to be honest. There may be some activist pressure, and there will be some noise about spending some money here and there, but that's about it. And so really, I spend a lot more time in understanding economics from a disaster perspective, and the actuaries are probably the best people to help us understand. the world finance at the end of the day has to spend money on green energy as well as the current energy structure and many other economic activities a day, but also have to worry about spending money when the extreme weather event happens and how much money of the economy is going to these activities. So they may have a much better feel for what are the global signs of warming and what are the risks that the society and economy is going to face. There was a report from Potsdam University just a couple of months ago. It basically calculated that a more than $200 billion economic loss in 2023 was attributed to climate change, and which was far more than 20 years of cumulative losses for previous 20 years before that. And it's largely because of the more frequent severe climate events happening all over the world. And they estimate that overall economic losses by 2050 related just to the more frequent and severe climate events would be close to $40 trillion per year. And there will be economic losses at a personal level, and the medium income losses they're talking about is close to 20%. And the poorest countries will be hit the hardest as per this study. So it's something you have to keep in mind. At the end of the day, the money is not infinite. Money will be allocated to various sources. And it's really the most important slide of my entire presentation. And so this actual professional view is that the cascading effects of the climate change and overall changes that are happening to the Earth systems, the carbon budget that people have talked about, this 2050, 2070, is far more optimistic. Our budget is far less. According to them, we have less than 10 years. And by the way, it's their analysis. Huh? And so what they're saying is for the financial resilience requires not putting undue weight on any energy transition. That is the most important conclusion. And they expect the involuntary mass migration because of a much higher temperature rise and sea level rise will be in the neighborhood of 300 to 500 million people. So it's not a small number. And certainly they expect that the Earth's GDP, they anticipate 15% GDP destruction between 2070 and 2090. And most assets are uninsurable as temperature exceeds 3 degrees centigrade. By the way, I spent part of my time in Tampa, Florida, and my insurance rates have gone up by a factor of 2 in less than 3 years. So this is something we see happening as I speak. And as the frequency of these disasters continue to increase, these costs will skyrocket. And that's something we need to pay attention to. So anyway, if I look at the current business as usual scenario, what is likely to happen? There will be a CO2 overshoot. We will invest in renewable energy to the extent makes sense, and where the government subsidies exist. But at the end of the day, today's economy is more important than ecology on a global basis. And there are a whole bunch of other technologies like, now you know all of them, whether it's BCCS or DAC, there are thousands of such things. I can give a talk on technologies alone if you want one day. But to me, none of them are going to cut it at the rate at which we need to do it, because the money is not there. And the government subsidies will run out very soon. And so if the temperature rises too fast and climate goes out of control, what would you do? And solar engineering is being talked about quite a bit, at least in the western part of the OECD countries. There are a bunch of things about adapting to the warmer world, and I'm actually in this bucket. We need to think about how are we going to adapt to the warmer world, worry about food, worry about water, and whole bunch of issues. I'll talk a little bit about later if time permits. Thirdly, what has happened is that there are a lot of geoengineering projects being talked about. The only one that actually has been proven is really sulfur aerosols. When we took the sulfur out of our fuels, the rate of temperature increase has gone up. Anticipation when the bunker fuel sulfur was taken out was 0.02 degrees. Actually, it is more than 0.2 degrees. So as I mentioned, the sensitivity of the Earth systems is far greater. So the albedo of the Earth has been reduced. And so people are thinking about, okay, it's a lot cheaper to put sulfur aerosols back in the lower atmosphere and reflect the sunlight, and it'll cool down the Earth. And that's fantastic. This can be done. It's probably the cheapest option amongst all geoengineering options. The trouble is the northern countries don't worry about the acid rains happening in the global south, because at the end of the day, sulfur has to come down. It will come down where it rains the most. And so the African countries are really getting worried, and they're actually trying to put a ban on such geoengineering solutions without some sort of a international agreement. Because rich countries or some even individual billionaires can do this if the Earth warms up where they live, if you will. So certainly it's the kind of things we need to worry about. So anyway, let me talk about the ecological disaster, which some economists talk about. And this has happened and been observed. It's happened to the ancient Mesopotamia and Mayan when they overexploited the resources. And you see that in the animal population when there are no predators, if you will, especially like the deer, they run out of the food to eat and then they collapse. In the human context, a collapse is the process by the end of which the basic needs like water, food, housing, clothing, energy can no longer be provided at a reasonable cost to the majority of the population. So the issue is not that we're going to go extinct. The issue is more about rich versus the poor. And at the end of the day, we are consuming resources. Some estimate is that 1.8 years equivalent of Earth. And so we are in the overshoot in some way of using Earth's resources. And so there was a model put together by some MIT folks in 1980s, a simple model which based on population, food production, natural resources, blah, blah, blah. And essentially, the model did predict there would be a collapse of economy. And I'm talking about industrial economy and a business as usual. And don't worry about the people being killed off in billions. And at that time, the whole conclusion was we are unlikely to change because politicians and businesses only have near-term incentives. And society as a whole, we are trapped in a prisoner's dilemma. This collective altruism is just impossible. But recently, Ernst & Young was asked to redo this study, and they just did it last year. And there's a nice report in a book actually written by this guy, Harrington. And she basically says the conclusions remain the same. The curves are about the same. But obviously she was asked that if you want to stabilize the world, what would you do? And then she did paint a picture and basically says that we can do it with the amount of money needed in a whole bunch of issues which are beyond we have ever done in our human history. And basically the bottom line of that whole study was we need to consciously limit industrial output on a global basis and material footprint. And so we need to move from essentially from never enough for each, from ever more to better. And is such a systematic change across the globe really possible is the real question. And so her conclusion was we are at a now or never moment in history for future trajectory for the rest of the century. And by the way, they're all economist views. I mean, I'm not talking anything about technology because technology, being in this business for 45 years, is such a small part in any of the stuff that we talk about. So anyway, so those economists also talk about degrowth. And basically they're saying we got to dematerialize the world, forget about GDP as a main metric, restructure the whole economy, and stay within the allowable carbon budget, relocalize the economic activities, develop sustainable lifestyles. Even the North Americans lived happily at a less than 50% consumption in the 60s. So what's wrong with that? And they also talk about reducing global population in a planned way, which is simply impossible in the next 50 years. So this is a theoretical view, but this is a one view that one need to think about. So there are two extremes. One is that the green energy is going to solve all our problems. Other extreme is we need to think about degrowth. And so how do we find a middle path is something I'll talk about. I read this book in 70s about Small is Beautiful. Perhaps everybody should read this one more time. But there's an interesting book written by this another economist called Kate Raworth. And I talked about ecological ceiling before and all the transgression that we have done. But she puts in another element called social foundation. And then she then buckets this between what is a safe and just space for humanity. Again, this is a romantic view, but this is actually far more progressive than the completely degrowth view. It's worth reading the book. And, basically she's talking about that we need to put higher prices on non-renewable inputs. And to be honest with you, when I put together this, I shouldn't say the team put together this economic model of the world, all these things were looked at, carbon taxes, this and other stuff. The only thing that made sense was putting a consumption tax based on carbon intensity. So it is the consumption that really matters, not this whole which country is emitting what. Because, countries producing something is consumed by someone else. It's the consumerism that actually is causing the problem. And so we need to move from this whole idea that today we're at a private luxury and a public squalor to public luxury and private sufficiency. And how do we get there? And so her approach is that could we start at a community level? And by the way, this is happening in some parts of Europe and Canada. And they are showing some promising results that at a local city levels or a small district levels, if you apply this kind of concepts, it is changing the behavior of the people. At the end of the day, it's going to come down to the behavior of the people. Since I'm a technologist at heart, let me talk a little bit about technology and what I'm proud of what a few things we did in India that are worth talking about. it all comes to boil down to in my head that energy. What is this? What is the excellent energy source? It needs a high energy, volumetric energy density. It needs to be portable. It needs to be stored and used at will. And it needs to be supplied uninterrupted 24/7 for the way we have structured our economies of today. And in my mind, there are only two sources of energy. One is the green oil that I'm going to talk about, and the nuclear. Other than that, all this other stuff is very expensive. And if you look at solar, wind, it's too dilute. It's not available 24/7. It needs very expensive, large scale, long duration energy storage. I'll talk quite a bit about this subject because we're all confused about the solar. And a solar today has only 4-hour battery. And maybe some people are talking about 16-hour battery. It's not going to cover what we need. And I'll talk about what happened in California and Germany to understand the impact on cost of electricity. But anyway, if we just historically looked at it, what has happened to humanity? We have moved from low energy density fuel to high energy density fuel. We moved from the wood to charcoal to coal to oil. And people talk a lot about hydrogen. It's great on a gravimetric basis, but you don't store hydrogen on a gravimetric basis. You store on a volumetric basis. So I've given the table of a volumetric energy density, and I'll talk a little bit about hydrogen if I have time. I've done a lot of work in hydrogen since 90s, if you will. But anyway, the whole idea that I had was if I can make green oil, which is equivalent to crude oil, within today's carbon cycle, with today's biomass, why would it not be even better? And I'll talk quite a bit about that. And now, if we took our last 40 years of investments in the nuclear industry, about $1.8 trillion have gone over the worldwide, and it produces about 6% of the worldwide electricity. About $2 trillion have gone into solar and wind. It's producing only 3% electricity. Keep those numbers in mind. By the way, the Indian nuclear is only 3%. I don't know why we're at 3%. We should be at 80% if you really want to be truly Atmanirbhar in energy. Basically, that's my personal view. Anyway, I'm really excited about nuclear energy, and I won't talk about nuclear because you're sitting in BRC. Probably you know a lot more about this, but I do understand something about nuclear energy. The small modular nuclear reactors are becoming a fashion of the day. And certainly, I don't understand why we are so slow with our thorium reactor. In 1999, I was told India is the leader in thorium reactors. Anyway, the small companies, startup companies are doing this sort of work. Chinese have already have at least a demo plant of a 4th generation nuclear reactor. But I'm more excited about the fusion, if you will, for whatever reason, since there was a positive gain at the Lawrence Liverpool National Lab. But more importantly, the amount of money it has been attracting from the venture capitalists is really enormous. And the most important thing the US government, the Biden administration has done is that it has taken fusion out of nuclear regulatory commissions. It has nothing to do with fission at all. And so they are actually doing a lot of public-private partnership. There are many companies, and I've been looking at some 35 different companies who have attracted each one of them, pretty close to $1 billion investment. And I just picked Helion because they have some interesting scientific concept. They're using helium, but more importantly, they are actually combining both the gravitational as well as magnetic confinement. And they're using both of them in this novel reactor. By the way, I'm a reaction engineer by training, so I get excited by reactors. And the other idea that they have is that they're extracting electricity directly from the plasma rather than any heating and then having a steam cycle, if you will. And they are promising that they will have a commercial facility by 2030. A Nucor utility in the US is investing quite heavily. And so are all the IT companies. And IT companies have a reason to invest because if they want to do this AI with this current technology or even the next version, the amount of energy that data centers are consuming will become a category by itself. So they have an incentive to do this, and they're doing this. So anyway, let me talk about my green oil. This is the idea that I've been promoting, and nobody's listening. And the whole idea is that what exactly is the food? What exactly is the human waste? Is nothing but the solar energy. It got trapped as a food. We ate it, and then some people are talking to me about converting our shit or poop to jet fuel, if you will. Nothing but any organic matter can be converted. And if you look at other than the metals and the glass, everything else can be converted. It's all organic to a green oil. And the amount of municipal solid waste we have, we can produce a significant amount of green oil. And if you look at the municipalities in India, they're actually growing much faster than anywhere else in the world. The way the cities are growing, will continue to have waste management challenges. Landfills are certainly not acceptable. And the Indian government is pushing on bio-CNG as if there's no tomorrow. I'll talk a little bit about that because what I'm doing is probably far, far better in terms of economics and in terms of actual energy recovery. So let me talk about what we did. There's a big pilot plant we built in Jamnagar, and it's been running for more than 80 years now. Now, I've been talking about it for at least 80 years, but nobody's paying attention. In India, I can understand because we are fast followers. If it's not been done somewhere else, we are shit scared, to be blunt with you. Anyway, we have this pilot plant. The size of it you can see from the bottom left-hand side, and the reactors are shown on the right-hand side. Basically, all kinds of different organic feedstocks with a simple some feed processing is pressurized in a reactor. And the idea is that we're using a catalyst and we're actually accelerating the same thing that happened in Earth's belly to produce crude oil in the first place. What exactly is crude oil? It's nothing but old sun trapped in the old biomass that got cooked up to make crude oil. And if I can do that within the current biological cycle, and I do this in less than 1 hour, by the way, residence time. And the amount of product I make is purely, almost all of the energy is green oil. A little bit of gas that is used to heat the process, if you will. So anyway, since we use catalyst, it improves the oil yield compared to many thermal processes. But most importantly, it deoxygenates. The calorific value of the oil I produce is very, very close to what the crude oil we use. And by the way, it is from the organic material of today. And keep that in your mind. And so, I won't bother with a couple of slides. Whenever I get involved, I'm doing fundamental work, perhaps far better than most professors. So, we have understood the chemical reactions, all phases, the very molecular-based fundamental kinetics to make a process completely feedstock agnostic. So I can use any feedstock because it's just like a crude oil refinery. I can process 1,000 different crudes in the same equipment. So if I'm going to put a capital, and in the agri biomass, for example, is not available for 365 days. A municipal solid waste is a variable. So I can use a whole variety of sources and to run the factory. So this is the most important slide. These are the economics. Today the Indian government is pushing for bio-CNG. It's a well-known technology, has been around. In fact, somebody told me it was invented by the Indian Institute of Science 100 years ago. And Germans and others perfected it, and we are very happy with it, right? Everybody's doing bio-CNG today. So if you look at this table, and just pay attention to the amount of product I make in terms of product. I make only 17, maybe 20% at best on weight basis, whereas in oil, I make 500%. Most importantly, I recover 70% of the energy from the feed as energy in the product. And it's more than all other alternatives. And if you look at the amount of capex involved for this process, it's a lot less. Obviously, you make a lot more profit and the payback is a lot shorter. And so if somebody were to ask me, hey, what is the price of green oil you'd produce? Today's $10 a tipping fee that is available in Indian cities. I'm at $30 a barrel. And at more than $30 a tipping fee is available in the rich countries, I'm at a zero or negative price of crude oil production. And I've been talking about this to various people, including our ministers. And the trouble in India is that we have subsidy for the final finished product, an ethanol or biodiesel or something. Country that imports so much crude oil has no interest in green oil. It's just amazing to me. I can convert any dam, including human beings. They are organic anyway. When they die, you can convert them to green oil, if you will. As nothing but the sun's energy stored as a biomass. You can take municipal solid waste, agri waste, dairy waste, anything else, and convert it to green oil. Anyway, my feeling is it will happen probably not in India, but perhaps in the Western countries, because incentives are far greater in the US alone. With the tipping fees in California at $85 a ton, the price of crude oil produced is $77. By the way, it doesn't take a lot of money to put up such a plant. But Reliance probably will not do it because we are in a waste management company and you don't want to deal with the municipalities, if you will. So somebody in government should take incentives. And I talk to ministers, but they simply don't understand because they say, has it been done before? It's not done before. Why are you talking to me? And I'll talk a little bit about what the Indian mentality about the whole science, technology, education, if you want me to. But anyway, let me talk about CO2 circularity. At the end of the day, you have to worry about CO2. You have to suck out CO2, both from the oceans as well as atmosphere. And so what will you do? And people are talking about making these low quality concrete aggregates, and that's a near-term opportunity. And so one thought we had was, if I can convert CO2 back to fuels, wouldn't that be nice? At the end of the day, it's all sunlight that we need to worry about. So by the way, we built a 60-acre facility. The idea here was that you take the CO2 from our refinery, petrochemical plants, use algae. And by the way, algae grow almost 50 times faster than the plants. And to be blunt with you, all the oxygen you eat is actually the algae in the ocean, available to do with the trees you plant. And maybe it will make you feel better. So the whole idea was that we de-risk every piece of technology of growing algae, and then converting that to that biomass, essentially on-purpose biomass. Because I did tell you, the amount of carbon we consume is 20 times more than the food we eat. There's not that much waste that you can convert back to oil to satisfy your needs. So you have to make some on-purpose biomass. And so the best biomass on purpose you can make using sunlight and CO2 is really algae. And if I were to build this at one time, I had this vision that I can convert the entire run of Kutch into a green oil field. If I can do that, the green oil production without any subsidy, without any CO2 credit, about $140 a barrel. Obviously, everybody gets worried if it's $140 a barrel. I can buy the fossil fuel at $80 and $90, where the hell it is today. But the whole issue is this is green, it's 100% green. And at the subsidies are in the US and Europe, probably all but $70. And the reason I'm so confident is because I did a lot of fundamental work on understanding photosynthesis. And I did tell you before what the ultimate sustainability is all about. And photosynthesis is the basis of all life on planet Earth. And just to show the power of what we did as engineering models, actually I spent a lot of time with everybody who understood photosynthesis. All the Nobel laureates and everybody else said, hey, I know something about photosynthesis. I got them all together for a week, locked them up, try to understand what is the state of knowledge and what do I need to do. So anyway, what these lines are showing are the model predictions of models, engineering models we built here in Reliance. And the dots are somebody else's data. This is the data from some Israeli group. And the point I'm trying to make is I predict my data far better than obviously somebody else's data. But if you have this ability to predict the biomass production, and essentially you have to understand how do the photons get converted to electrons and protons, and how do you form this biomass. And it's really most biologists got really surprised when I told them, if I were to cover part of the pond, actually shade it, my biomass productivity will go up. And that's exactly what happened. This is what we have shown in our facility, in our pilot plants in Jamnagar. And so my current thought process is that since we're building the solar panels, why not build these algae ponds? Because it will become energy source and also improve the solar productivity a little bit. And we are applying this knowledge of understanding photosynthesis to agriculture to some extent, but not for energy production today. So anyway, everybody's all gaga about solar. So let me give my comments about solar. Solar makes sense. We absolutely must do it. We must do wind, everything. It's necessary, but not sufficient. And everybody talks about the LCOE. The cost of electricity production from a solar panels is cheaper than any fossil fuel. That's great. I agree with that on a project basis. It doesn't deliver you 24/7 electricity to a consumer, for which you need a very, very expensive storage option. I'll talk about that in the next couple of charts. But we must thank Chinese. They have reduced the cost of solar panels by 2 orders of magnitude. And if we really want to be king of hydrogen, this is something we need to think about. How the hell are we going to get the cost down, especially the transportation and storage, if you want to become a king of hydrogen? We're not going to do that by just applying a bunch of electrolyzers here and there and hoping somebody will buy our expensive products. Maybe in short time they will. It's not going to solve a long-term problem. So anyway, coming back, this is something we must, and by the way, the technologies for all renewable energies are with Chinese today. They are not in the West. They were developed one time before. You may not know this, but anyway, I'll talk about this a little later. So, I was doing a mental exercise saying, I know something about sunlight because I've been growing algae for the last 10 years. So I said, okay, let's look at, I want to run the Jamnagar refinery 100% on just solar energy. What will it take? And so here what I'm plotting is, say the blue line is what the amount of electricity I need. I'll finish it in the next 15 minutes. The bottom line here is that I need to store energy for at least 30 days. And you can become bigger solar plant, it will take you 7 days. Without 7 days storage, you're not going to be able to afford 24/7. Today, there's a grid, unless you put a large amount of nuclear energy. So anyway, a lot of people are talking about all kinds of batteries, mechanical batteries. Lithium-ion battery is probably the most, by the way, you may not know this, but the renewable lithium-ion battery was invented by ExxonMobil scientists, just for your reference, so you can go back and check. So all these technology options are more important. I'm saying you just burn this green oil and make electricity on purpose when you need it. And so if you look at the life cycle cost of storage alone, the green oil is much cheaper. And we've been burning green oil. We're burning diesel in reciprocal engines anyway. So this is what it is. So my proposal is that you make green oil and you burn it whenever you need it on demand. You can balance the grid far better. And if as your amount of energy storage requirement and number of days goes up, the oil becomes much cheaper. It's easier to store, easier to transport. So these are the cost of various batteries. I just took lithium-ion battery with the solar. Say I need to store 24 gigawatt hour of electricity production for 7 days. There's no cost no battery will ever compete with just burning pure oil. By the way, if I put those ponds I was talking about under the solar panel, the cost of oil will go down by another 25%. If I genetically modify algae, which I can do today, the factor of the cost will go down by 2. Indian government will not allow me to put genetically modified, but they are talking about now some CRISPR. And by the way, we've done many technologies where I'm converting using algae as a platform to make anything you want. We are today going to produce protein commercially, especially iron-fortified proteins, because that makes sense. Indian vegetarian food is iron deficient, and a whole bunch of other products. So anyway, people talk about AI and fourth industrial revolution being digital. To me, from a climate change perspective, it's far more to do with biology. And if we don't focus on biology, we will not be able to meet our future food need. So anyway, so why isn't the climate change a sustainable mass movement? It's simple. Because in today's version of the climate change, it is too off-putting. There's nothing, there's no hope. Yeah, you can hope about green energy saving us, but will the industrial capitalism that promises everything now, will it be able to solve this problem? Because today the growth is unquestionably good. And in my mind, this is unlikely to happen with a capitalistic model. And so how do we give a positive message? And perhaps this is where AI could help. Because in my mind, the media proliferates convenient narratives, false equivalency, voice to influential technocrats and business tycoons, with perhaps disingenuous, hopeful messages. So we are essentially, we are in this boiling frog syndrome. Because the scientists on one side are saying, and everybody's saying they're doomers, like some of the messages I gave you earlier. Same thing that's being said by politicians and business figures is saying, oh, we are just a few technical fixes away. And to be honest with you, this is not going to cut it. We need a different path. It is not techno-optimism. It is not degrowth. And so how do we do something which has a mass appeal, the immediate benefit? I know many people who are given hopeful messages and made a career out of it without doing a damn thing. So anyway, I would not bother you with the capitalism, but essentially, if you look at all the green capitalism that is being talked about today, who are the people behind it? These are people like BlackRock, and these are the asset managers. In fact, today, more than just a handful of people control more than $100 billion plus economy. And they are the ones who influence the US policy of spending $370 billion in this so-called Inflation Reduction Act, or similar thing in Europe. And so the basic message is carbon pricing, more than likely, is not going to solve any problem because it's still tethered to a profit motive. In my mind, it will quickly exhaust government subsidies, and the GDP alone will not be able to solve this problem. So economic resource allocation for disaster management that actuaries were talking about at a $50 trillion a year will start to compete with putting investments in this renewable energies as well. So this is something we need to think about. So anyway, I won't bother you with this post-growth economics. It's a theoretical concept of a negative interest rate. Essentially, it's not going to do anything. So I was thinking about in the Indian context, if you really want to do this Vasudhaiva Kutumbakam, can we go back and think about the Sanatana economics philosophy? And I won't bother you with the aspects of what it is the communal harmony. It is an ethical, reasonable profits. It's sufficient resources for adequate quality living and access to be given to disadvantage. And that is really the message of one earth, one family, one future. Giving up something for the common good. And how do we do this? And this is where I think the AI could help, because AI can influence large population as it can narrate stories at our individual level of understanding. It's very similar to the spread of faith and religion in some way. And so really, all of you are aware of the Indian philosophies. I won't bother with you this. But how do we do this? And this is a challenge, and perhaps some of the principles of the ancient Indian civilization, if we can communicate them with the current AI to the global scale, perhaps we can go beyond the messaging of Vasudhaiva Kutumbakam. Now, I was going to talk about hydrogen. If you have 5 minutes, I'll talk about it. If not, I can some other time come and talk about technologies till the cows come home. But essentially, to me, I'll just spend 3 minutes. Hydrogen is useful. It can decarbonize the heavy industries, steel, cement. Today, hydrogen is produced and used at the same place. There's no place other than a few places in Texas and in Europe where there are hydrogen pipelines, and they are not that critical. Anyway, the cost with the green hydrogen of electrolyzer is today somewhere in the neighborhood of, depending on who you talk to, $4 to $6 a ton. We have invented a technology here in India where I can make the hydrogen from biomass at the same cost as the steam methane reforming. I've talked about this before. The cost of hydrogen really hangs on the transportation and storage, and we need some major inventions, not some incremental innovations is going to do this. So my idea was that today we are burning agricultural waste. I can convert that to oil that I talked about. And since everybody's talking about hydrogen, I said, okay, let's convert that to hydrogen. Actually, I developed this technology for actually our high ash coals to make India energy independent. But obviously, the same question came up. We invented a new catalytic, a migratory catalyst. Actually, I wrote a paper on this sort of a concept. I can use a solid catalyst to actually gasify solids. That's the whole idea. And we had done that, a fairly large pilot plant, by the way. And it's a steam gasifier at a much lower temperature. So both capex and opex is significantly lower, 40% lower than the thermal gasifiers the coal India is talking about today. And essentially, I convinced our management that we should put up this for hydrogen. I don't know if it'll happen or not. They're talking about it. But the whole idea is that I'm using air to burn the catalyst, coke on the catalyst that supplies the heat of endothermic gasification reaction. The only point I want you to make here is that we need to talk about inventions. No innovation is going to make any difference to the world. And if we don't think about inventions, we're not going to change the world. So anyway, since I came to India 16 years ago and I didn't have facilities before I built them, in fact, I built one of the most sophisticated R&D facility, not just in India, probably in the world. And I can talk about that as well if you're interested. And work a lot with the whole variety of universities, national labs. And their expectation was like this baton race, they'll do something and give it to me. We need a much closer public-private partnership. We need a truly end-to-end engagement. Most of the valuation of these expectations from the national labs is way too high for the amount of stuff they actually produce. Prime Minister Modi talked about we had to leave our servitude mindset behind in, I guess, 2-3 years ago. I've been talking about for 16 years. Forget about this sir, yes sir nonsense. The British left 75 years ago, and we really don't mean anything about sir, yes sir. It's all gotten into our mindset as if it's something we had to live by. The bottom, I stole these last two figures from Dr. Michelker. Basically, it says the herd mentality. There's no real fence, but the sheep is going following the leader. We need to break away from the flock. The world is changing so fast. There's the fourth industrial revolution or climate change. With the old investments in the West compared to where we are, we just don't have to be fast follower. If we remain fast follower, we'll never be catch up with the first mover. And this is my simple advice. In India, to be blunt with you, we don't have any capacity to do translational R&D for high capital intensive industries. And what has worked for digital technology is not going to work for energy transition at all. If at all we want to do something which is first to the world. And perhaps we need to learn something of the musicians. Here, Zakir Hussain is playing with the West. Obviously, we need to collaborate with others. We can build on the AI-enabled collective connected ingenuity in today's boundaryless world. This is my last slide, by the way. I talk a lot about this. To me, I in India should be inventions. Innovation is for application, whether it's your technology or somebody else's technology. If it is your technology, it's cost competitive, you will get a long-term competitive advantage. So science is for solution, technology is for transformation, but implementation for societal impact is far more important. And if you look at Mahatma Gandhi's message, he talked about inventions. Nowhere did he talk about innovation. Innovation is incremental in my head. It's for application. Don't get me wrong, you need innovation. And we have 100 flavors of innovation in India. But nobody in our community talks ever about doing something breakthrough, inventions. And this is the time we start talking about inventions if we really want to climb the ladder of prosperity and be better than the world. To be blunt with you, our GDP will grow, but GDP per capita hasn't changed for last 70 years. So anyway, the problem, the way I talk about education as well, if you want to hear my thoughts on education, I'll give you another separate talk. The problem is not people being educated. The real problem is they're educated just enough to believe what they have been taught, but not educated enough to question what they have been taught. And so again, I'll bring back to Mahatma Gandhi. If you want to use AI, if you want to use this whole Vasudhaiva Kutumbakam across the globe, Perhaps there's a bridge from the ancient past to today's future if you use some of this concept of Gandhiji's. I think this is my last slide. I especially talk to young people when they come to my office and they tell me about, oh, they work for this famous professor. This. I said, forget about all that nonsense. You start something unknown and finish something unforgettable. This is your opportunity. Forget about who did what and when. Think on your own and do something, because we are entering an era of cognification. Either AI will kill us or climate change will kill us. We have a choice and we need to choose wisely. I hope I did not ruffle any feathers. I didn't mean to. I just wanted to raise the bar of the conversation, because most of the conversation of scientific and engineering in India are simply me too and some incremental stuff where we get excited about. I really mean no evil. I hear no evil. I speak no evil. Having been in this business for more than 40 years, I'm convinced there is no planet B. There are only a few people can go to Mars with Musk. So thanks for this opportunity. I hope I did not upset anybody, but if I did, that's okay. Maybe you'll get something out of it. If nothing else, it was entertaining, I hope. Thank you.
Thank you, Dr. Sapre, for a very comprehensive coverage on all the aspects of energy, economy, climate change, and the cultural background and the way forward for this. I think I don't know whether you attended the general body meeting. Some of your points have been well taken and discussed during our planning for the year. And we are going to have many more talks on these topics, related topics.
Mr. Sapre, can I ask you a question?
Yeah, ask any question.
You
You
have
can
been
ask me about Bollywood, Hollywood, politics, whatever you want.
green oil, and Reliance has been working for a long time on this. What is the current status of this technology? At what megawatt or whatever unit?
No, I think you have to understand that. See, I talked about making electricity, right?
Yeah.
Burning electricity from green oil, because you have to understand the electricity is probably the most flexible form of energy.
Yes.
And the demand will grow because of the higher end use efficiency. And I'm really worried that if you just look at what happened in California or Germany, when they went way high up, more than 40% on the grid became unstable. In fact, they had to pay somebody to take the electricity away. See, at a low level of penetration of solar in India, we are okay. But once you go to 40%, 50% intermittent electricity, you need a storage of the kind I'm talking about, not some 4 hours or one day. And then it becomes very, very expensive. And this is where the burning green oil comes into picture. Now you have to understand, the Reliance is a fairly complex organization with multiple organizations. And since I talked about economics, you have to look at the way in which the geo business and the retail business is growing compared to the energy business. And there's a lot of emphasis on this so-called new energy. Whether we have built a big solar manufacturing, panel manufacturing. We're building a lot of solar factories. The question about the green oil, I don't think anybody understands what I'm talking about, to be blunt. Neither the government nor the people who have to. And by the way, when I talk about a green oil commercial plant, I'm looking at $2 billion. So when it comes to spending a $2 billion to go beyond, I have a 60-acre facility. I can produce about a quarter barrel a day of green oil as a concept. And the near-term opportunity to me is not algae, because algae is far more complex. I've done a lot of fundamental work on synthetic biology and other areas to make this thing robust. But the municipal solid waste, I don't understand why we are building these biogas plants. They're not that economic compared to if you were to convert the same feedstock and get 70% energy of the feed into green oil. And Reliance is not interested primarily because we are not into waste management. The businesses want to have some control over feedstock to the product. You can understand that, right? So it's really the governments have to take an initiative. And every time I talk to ministers, they say, oh, we have incentives for the biofuels. I said, India imports so much oil. I'm making green oil distributed way at $30 a barrel. We're trying to buy Russian oil, saying, oh, I got some discount. That's our mentality. You can help me change it.
Any other question? online logo.
By the way, I'm very blunt because for me, at my age, it's black and white. There's no shades of gray. I mean, I can talk political and be shades of gray if you want to be nice and this and that. It's not going to solve any problem in the world.
Online participants, if they have some queries, they can ask, or you can email to him also, I think. And
Yeah, I'm available. I can answer, and I can answer any question, by the way, not just this topic, any other topic. I have plenty of ideas on all kinds of things. See, the whole idea for me to talk about this subject was more to raise the bar about the conversation that one needs to have. I think this whole thing started because somebody on WhatsApp wrote something and I reacted inadvertently, and people got excited. Yeah, it's okay. It's if you don't get people excited, they wouldn't know what the hell they're missing. And let me be blunt. I'm always blunt. Don't worry about it. I like the conversation when somebody says you're full of shit. That's only when some meaningful conversation can happen. Otherwise, it's all, sir, yes, sir, I scratch your back, you scratch my back, nothing happens.
so we hope that you will be available for future webinars and meetings on the related topics, and your views can be taken for general discussion and way forward. So with that note, I thank you again for being our speaker of the day.
All right, thanks, guys. Bye.
Thank you. Thank you very much.